Hey guys, so today I'm going to be talking to you guys about evaluating classifiers, or more specifically the confusion matrix. It was a little difficult for me to understand all the terminology associated with the confusion matrix, so that's kind of what my main focus is going to be with my presentation today. So to start with, what exactly is classification? Well, we all know this. It's a technique to predict what group a certain instance is going to fall into. For example, whether a particular person's loan will be approved or not, or whether this person, what level of life insurance a certain person is eligible for, is all determined by one of these techniques. So, excuse me. So to create classifiers, how do we do that exactly? We have a set of learning data, and we generate the classifiers based on that set of learning data. Then we take the classifiers that we get and we evaluate using test samples. And after we've kind of run it through tests and we kind of see it works, everything is good, then we'll be able to use it on new examples to predict what class they would fall into. So the confusion matrix, what exactly is it? It is a way to describe how well a classification model does, how well it's doing. Is it really good at predicting the outcome? Is it kind of sort of good? Is it not even worth our time to use? So this kind of helps us know how well a prediction, our classification model is working. So in the instance of the loan approval, your loan can either get approved or denied. So you have two different classes that a case can fall into. So in that case, we would have a 2x2 matrix with our predicted outcomes here and our actual outcomes here. And so we kind of want to keep everything either true positives or true negatives. The false positives and the false negatives, not so good, and we try to stay away from them. If we have more of those two, then typically our confusion matrix isn't going to be that great. So now the terminology that I was talking about. So we have accuracy, which is the proportion of predictions that are right. So how often your classifier is correct. And then we have the recall, which is the positive cases that are correctly identified. How many cases how many cases are positive and correctly identified. So one of the things that I found interesting was with skewed data, the accuracy seems to be not as accurate when the data is skewed, which we would see in the case of fraud detection, because, we have, thousands and thousands of cases where there is no fraud and it's just people using their cards regularly. And then you have this one case in a whole bunch of them where you catch the fraud, where there is fraud occurring. So there is a skew of 1 to 100 in fraud detection. And so then the accuracy calculation can be a little bit misleading in that case. So what I did was I included some links that I found helpful with understanding the confusion matrix, more importantly, the terminology associated with the confusion matrix. I hope this was helpful to someone, and that is the end of my presentation.